Welcome back to the MbaguMedia Tech Talk podcast. Today, we're diving deep into something that's absolutely critical for software development, yet often overlooked: the generation of production-ready test data. We'll be exploring Polyfactory, a tool that's revolutionizing how we approach this challenge.
That's right. For so long, mock data generation has been this tedious, error-prone bottleneck. It directly impacts how quickly we can iterate and the ultimate quality of our products. But what if we could turn that chore into a strategic advantage? That's precisely the paradigm shift Polyfactory offers.
Exactly. Polyfactory isn't just another library, it's positioned as an architect for building sophisticated, maintainable data pipelines. It abstracts away complexity, integrates beautifully with Python's typing system, and empowers developers to create intricate data generation strategies, all starting from simple type hints.
Imagine generating a complex, multi-layered data structure, like an e-commerce order with nested items, shipping, and customer details, not through verbose manual instantiation, but dynamically from a few elegantly defined type hints. That's the promise of Polyfactory, and it fundamentally changes quality assurance.
Let's start with the foundation, moving from basic structures to domain-specific realism. Polyfactory's core principle is incredibly simple yet powerful. It intelligently infers data types directly from Python's built-in data classes.
So, as you define your data structures, you're already setting the stage for realistic mock data. The data class factory is the key tool here. It effortlessly handles lists, nested objects, UUIDs, and dates without needing explicit configuration for these fundamentals.
To really see this, let's consider a simple person object that includes an address. When you define these using data classes, Polyfactory's data class factory automatically understands the relationship. It knows a person has an address, and it generates both, creating that nested structure.
That automatic relationship mapping is a massive time saver. It's not just about generating strings or numbers, it's about understanding the data's structure and populating it intelligently. And for testing, reproducibility is king, right?
Absolutely. The __random_seed_attribute is crucial for that. By setting a specific seed, you ensure the pseudo-random number generator always produces the same sequence of data. This is invaluable for consistent testing environments, allowing you to isolate bugs without the data itself being a moving target.
But realistic data isn't just about structure, it's about content. This is where integrating with libraries like Faker becomes a game changer. It allows us to populate fields with data that feels genuinely localized and real: names, emails, addresses, phone numbers.
Instead of a placeholder string for an email, you can use Faker to produce a plausible company_email. This shift from generic to specific, realistic data is fundamental to building tests that truly reflect how your application will behave in the wild. The mechanism for this is quite elegant.
It is. By defining a class method within your factory that matches an attribute name in your data class, Polyfactory uses that method for generation. So, if your person data class has an email field typed as str, you can define a class method named email in your person factory that calls self__faker__company_email.
That simple pattern lets you imbue mock data with the richness of real-world information. However, it's crucial to remember that while default generation is powerful, true production-grade data requires intentional customization. The real value comes from actively shaping that generation process.
Exactly. Which brings us to orchestrating complexity, calculated fields, constraints, and interdependencies. Static mock data often falls short when dealing with real-world application complexities. Data isn't always static, it frequently has derived or dependent values.
Think about an e-commerce product. Its final price is calculated based on the base price and discounts. Or an order's total amount is the sum of its items. Polyfactory shines here by allowing us to model these business rules directly within our factories, primarily by overriding the build method.
Within that overridden build method, you can implement post-generation logic. For instance, in a product factory, you might define price and discount_percentage, but then calculate final underscore price based on those after the instance is created. This embeds business logic directly into data generation.
And consider generating a SKU for a product. It often involves combining the product ID with a sanitized name. The build method override is perfect for this. After product underscore ID and name are generated, build can combine them, perform transformations like uppercasing, and assign the result to SKU.
That capability extends to optional fields and conditional logic too. For an order object, shipping underscore info might only be present if the order status is shipped or delivered. In the order factory build method, you can check the status and conditionally create and assign shipping info.
This ensures your mock data adheres to potential business states and relationships, making tests more robust and reflective of actual application behavior. It creates a ripple effect, making the entire generated object a more accurate snapshot of a real-world entity.
The overarching insight is profound. Embedding business logic into factories transforms mock data from static placeholders into dynamic, intelligent representations of application behavior. This makes tests more accurate reflections of how the application will actually perform.
Now, let's talk about bridging the ecosystem. Pydantic and Attrs for validated, production-aligned mock data. Data validation isn't a luxury, it's a necessity. Libraries like Pydantic and Attrs enforce data contracts, and Polyfactory integrates seamlessly with them.
It doesn't just generate data, it generates data guaranteed to conform to your Pydantic models and Attrs classes. When you use a model factory or data class factory with Pydantic, the generated data passes validation checks without a hitch. This is critical.
The mock data isn't just structurally similar, it's structurally compliant. Consider a Pydantic model for a payment method with conditional fields based on type. Polyfactory can generate instances that correctly satisfy these requirements, ensuring tests validate actual application logic, not just basic types.
Similarly, Attrs classes have their own mechanisms, like Attrs.field, factory equals list, for fields defaulting to an empty list. Polyfactory's Attrs factory recognizes and correctly handles these factory-based defaults, respecting the defined class behavior.
Specialized factory classes like Model Factory for Pydantic and Attrs Factory for Attrs streamline this integration. They're tuned for the nuances of their respective frameworks, generating data for enums, union types, and optional fields while maintaining validation integrity.
The strategic advantage here is undeniable. Generating mock data that is structurally compliant with your application schemas builds a more robust testing suite. You catch validation errors earlier, gaining confidence that your code will behave as expected with real-world data.
This versatility makes Polyfactory a universal solution for diverse Python projects. The pivot is clear, its power isn't limited to basic structures, it's about ensuring your mock data is as production-ready as your code. This leads us to fine-grained control.
Right, because while random generation is great for broad testing, deterministic testing is crucial for specific scenarios. Polyfactory offers powerful mechanisms for this fine-grained control. The most straightforward is direct overrides during build or batch calls.
If you need to test a specific user, say Alice Johnson, age 30 with a particular email, you can simply call personFactory.build, name equals Alice Johnson, age equals 30, email equals alice@example.com. Polyfactory generates the other fields randomly but uses your provided values.
That's incredibly efficient for crafting targeted test cases. Beyond direct overrides, there are use and ignore directives. Use is perfect for injecting fixed, non-random data into specific fields, like ensuring app_name is always myAwesomeApp.
You'd assign use, lambda, myAwesomeApp, to the app_name attribute. On the other hand, ignore is for fields you explicitly don't want the factory to generate, perhaps because a database sets a created underscore at timestamp automatically.
The power of targeted batch calls is also worth highlighting. You can generate multiple instances with a common override. For example, personFactory.batch 5 bio equals VIP customer creates 5 person objects, each with bio set to VIP customer.
This is a highly efficient way to create variations for testing. It leads us to the concept of coverage testing. By using overrides, use, and ignore strategically, we can construct variant instances to ensure all code paths and edge cases are exercised.
Imagine generating a set of payment method objects where some are cards, some bank transfers, some verified, some not. This comprehensive approach ensures we're testing not just the happy path, but also real-world variations and potential failure points.
The core insight here is that precision in mock data generation is paramount for effective testing. Polyfactory doesn't just offer randomness, it provides the granular control needed for both broad and deep test coverage, ensuring every aspect of your application is validated under realistic conditions.
This brings us to a crucial point: Polyfactory as a production data strategy, going beyond just testing. It's time to shift our perception of mock data generation from a necessary evil to a foundational element of the entire development lifecycle.
Polyfactory's capabilities extend far beyond unit tests. Consider populating development databases. It can generate thousands or millions of records mirroring your production schema, providing a rich environment for development and debugging, far more efficient than manual entry.
API contract testing is another area where it shines. When defining interfaces between services, ensuring data exchanged conforms to a shared schema is critical. Polyfactory can generate mock requests and responses adhering to these schemas, allowing rigorous testing of integration points.
And for performance-sensitive applications, Polyfactory can generate realistic datasets of varying sizes for benchmarking. This helps identify bottlenecks and optimize code under conditions closely resembling production load. Prototyping new features also benefits immensely.
Before full implementation, you can use Polyfactory to simulate user data and interactions, providing a tangible, data-driven way to explore new functionalities and gather early feedback. The synergy between Python-type hints and Polyfactory's generation creates a truly declarative, scalable approach.
As your application's data models evolve, your factories can evolve alongside them with minimal effort, maintaining consistency and reducing the burden of keeping test data up to date. Polyfactory fosters a data-driven by design culture.
It encourages developers to think about data structures and their implications early, integrating data generation as a core part of the workflow. Looking ahead, we could see deeper integrations with schema definition tools, perhaps generating data directly from OpenAPI or GraphQL schemas.
The final pivot is this: by mastering Polyfactory, development teams can transform mock data generation from a tedious chore into a strategic asset. It's a tool that accelerates innovation, builds confidence, and leads to more reliable, resilient software.
It empowers us to build not just code, but entire systems that are robust, adaptable, and ready for whatever the real world throws at them. So, in conclusion, Polyfactory is truly an architect of confidence.
We've journeyed through the multifaceted landscape of mock data generation, and it's clear Polyfactory is a beacon of intelligent design and practical utility. It's not just a library for test data, it's a sophisticated architect for building robust, production-ready data generation strategies with ease.
Its core power lies in its declarative nature, elegantly leveraging Python's type hinting. By letting Polyfactory infer and generate data, we drastically reduce manual instantiation and scripting, enhancing maintainability and reducing errors.
The integration with Pydantic and Attrs is a game changer, ensuring test data is not just syntactically correct but semantically aligned with our application's data contracts. This coupling provides profound confidence that our tests truly reflect real-world conditions.
And the ability to handle complex relationships, calculated fields, and conditional logic within the build method allows us to simulate intricate business scenarios with precision, further solidifying this confidence.
Furthermore, Polyfactory's capacity for fine-grained control through overrides, use, and ignore transforms it into a precision instrument for targeted testing. This control is key to crafting test suites that achieve comprehensive coverage and mitigate risks.
Perhaps most compelling is its evolution beyond testing. Its application in populating development environments, API contract testing, performance benchmarking, and prototyping demonstrates its strategic value across the entire software development lifecycle.
It fosters a culture of data-driven development, where data considerations are integrated from the outset, leading to more reliable and adaptable systems. By embracing Polyfactory, we embrace a more intelligent, efficient, and resilient approach to software development.
So, let's summarize the key takeaways. The core is declarative data generation, leveraging Python-type hints for maintainable and understandable mock data. This integrates seamlessly with Dataclasses, Pydantic, and Attrs, aligning mock data with actual application models.
Absolutely. Then there's the strength of generating realistic and domain-specific data, especially with Faker integration. This is crucial for testing edge cases and ensuring robustness. The ability to inject custom logic further tailors data to business needs.
The fine-grained control and determinism are huge strengths. Overrides, use, and ignore directives allow for deterministic testing and specific scenario testing, which is essential for debugging. The batch functionality with overrides is particularly useful for generating related data sets.
And the ecosystem integration with validation frameworks like Pydantic and Attrs is a major advantage. It ensures mock data is not just plausible but compliant with application schemas, bridging the gap between testing and production data integrity.
Finally, its utility extends far beyond testing, populating dev databases, API contract testing, performance benchmarking, and rapid prototyping. This positions it as a strategic tool enhancing the entire lifecycle and fostering a data-driven development culture.
Looking at challenges and opportunities, while declarative generation is powerful, there can be a learning curve for advanced features. Misinterpreting definitions could lead to unrepresentative mock data, so careful design and maintenance are key.
Achieving true domain-specific realism requires deep understanding of the application and Faker or custom functions. There's an opportunity for more sophisticated strategies to combine data sources or simulate complex relationships, balancing realism with performance.
Regarding fine-grained control, over-reliance on hard-coding specific values can lead to brittle tests. The opportunity lies in strategically using these controls for critical paths and edge cases, and managing seeds for reproducibility across teams.
The validation integration's effectiveness depends on the quality of Pydantic/Attrs definitions. If models are inaccurate, generated data might still not be truly representative. There's potential to enhance integration with other schema tools and provide clearer guidance.
And for its broader applications, educating teams on Polyfactory's utility beyond testing is an opportunity. The challenge is integrating it seamlessly into diverse workflows and demonstrating its ROI. Building further tooling for CI/CD pipelines is also a clear path forward.
It's clear that Polyfactory offers a robust solution for mock data generation, empowering developers to build confidence and accelerate innovation across the entire software development lifecycle. It's a tool that truly architects resilience into our applications.
That's a fantastic summary. We've covered the introduction, all 5 sections, the conclusion, and the detailed summary. Thank you for joining us on MbaguMedia Tech Talk.
It was great discussing Polyfactory today. Join us next time for more insights into the tech world.